Now we're going to look at some new types of counting problems involving subsets, bit strings, and lattice paths, and in particular looking at the connection between these three different types of counting problems. First, we're going to note how the videos in this section are a little bit different than the ones in the other ones, and I'll explain why in a little bit. We're going to review the definition of what a subset is back from section 0.3. We're going to define what it means to be a bit string and what it means to be a shortest lattice path between 2 points on the Cartesian plane. And then we're going to give examples of the kind of counting problems we encounter with each of these types of concepts. Alright, so just to give you an overview, this is how the videos up to now have been designed. I explain some new material, I do some examples of some basic problems related to that new material, and then that will hopefully lead you into the class activities. This section is a little bit different. I'm just going to introduce some new concepts, give some definitions. I'm going to describe the types of counting problems we work on, the concepts, and then I'm going to let you explore some of the counting techniques in the class activities. I'm going to lay back on the examples for this one so that you can sort of explore how to do these problems. However, at the end, I'm going to have a video that kind of summarizes everything that we do in these videos. So these videos kind of set you up for the in-class activities. You work with them a little bit, but then we come back and explain what it is that you learned in those activities. So I will explain these techniques to you in the videos, just not right away. So let's remember what the definition of a subset is of a given set. So if you have some set A, we say that B is a subset of A, and that is written in that way. B is a subset of A when every element of B is also an element of A. And again, it doesn't necessarily work the other way around. It doesn't necessarily have to be the case that every element of A is an element of B. So here's a typical counting problem that you might run into with subsets. Suppose you have a subset A that has 5 elements in it, the numbers 1 through 5. Question you might ask is, how many subsets of A have 3 elements in them? Or more generally, if A is a set with n elements, so the cardinality of A is equal to n, and if k is some natural number that is n or below, then how many subsets of A have k elements? So you're going to work in your in-class activities on a problem where your subset A has 7 elements, and you are going to count all the elements with 4 elements, or all the subsets with 4 elements, excuse me. Alright, the next issue that we're going to deal with is something called a bit string. And all a bit string is a sequence of zeros and ones. And so, for example, if you look at the string 0, 1, 0, 0, 1, 1, 1, 0, 1, that's a bit string. I just randomly put some zeros and ones in order, and that gives me a bit string. So it doesn't seem like the most exciting thing to study, except, well, this is actually something that's important to you folks. First of all data that is stored in a computer is stored as bit strings. We encode characters that we write as bit strings as well. ASCII is the most common example of this. A bit string can be interpreted as representing a natural number. And actually, you can represent integers as well if you use something like 2's complement. Or there's some other techniques as well, but 2's complement is, I think, the most common one to use. And then also, we can use bit strings to solve some counting problems. So before I tell you some of the problems that are related to bit strings, we're going to do some definitions. First of all, if you have a bit string, one of the things you might be interested in it is how long is it? So the length of a bit string, and that is just the number of digits that the bit string has. So if a bit string has length n, we call it an n-bit string. We also might be interested in what's called the weight of a bit string, and that is how many ones are in the bit string. So remember, the bit string can have a bunch of zeros and ones. The weight just talks about how many ones are in that bit string. So if we have the bit string 0, 1, 0, 0, 1, 1, 1, 0, 1, that one has 9 digits, so the length is 9. So we can say the length is 9, or we can say that it is a 9-bit string. If we want to count the number of ones in it, that 5 of them are ones. and so that means the weight of that bit string is 5. So here is a typical question you might ask about bit string. Not the only question you might ask, but a typical counting problem might be, how many 9-bit strings are there that have a weight of 5? We just had one up there in the example. How many others are there? The last concept we're going to talk about in this particular video is something called lattice paths. So to get started, let's remember our old friend the Cartesian plane, and that's just the plane with an x-axis and a y-axis, like we were talking about back when we were doing Cartesian products. And suppose we have 2 points on the plane that have integer coordinates. What that means is the x-coordinate is an integer and the y-coordinate is also an integer. And so here are our 2 points. A shortest lattice path between the points A and B is something that, well, the path is taken in discrete steps, right? So you can't take like half a step or a quarter of a step. You take one step at a time. And then each step is either to the right or it's up. So no diagonal steps. And each step has length 1. So you can step to the right 1 or you can step up 1. Those are your choices within your path. So for instance, we could do something like, okay, so here is our coordinate setup, and you can see that A is at the point 1, 1, and B is at the point 4, 3. So one way to get from A to B in the shortest way possible by taking discrete steps of length 1, either right or up, is you can start by taking a step to the right from A. You can see that little step to the right there. We can take another step to the right if we want to. We can take a step up if we want to. We can take another step to the right. But now we have to take a step up to get to B. That is one example of a shortest lattice path from A to B. And you can see that we're going to take 1, 2, 3, 4, 5 different steps. And actually, no matter how we get there, we're going to take 5 steps, because at some point we're going to take 3 steps to the right, and we're going to take at some point we're going to take 2 steps up. We just have to figure out what order that we're going to do those things. And of course, that's not the only shortest lattice path that we can take from A to B. Here's another one, for instance, and there are a whole bunch, and you're going to be able to count them. So when we talk about shortest lattice paths, it's any path between A and B where each step is either to the right or up. So here's a typical counting problem involving lattice paths. Given 2 points A and B with integer coordinates, how many shortest lattice paths are there between A and B? So here's what you're going to be doing in your class activities. First of all, you're going to determine how to solve the counting problems that we talked about for bit strings, for subsets, and for shortest lattice paths. The other thing you're going to do is you're going to find the connections between these 3 types of problems, because they don't look like they're the same, but it turns out that any subset counting problem that you have can also be interpreted as a bit string problem and also interpreted as a lattice path problem. Similarly, every bit string counting problem can be interpreted as both a subset counting problem and a lattice counting problem. And then finally, every lattice path counting problem can be interpreted as a subset problem and a bit string problem. So subset problems, subset counting problems, bit string counting problems, lattice path counting problems are in some sense, they're not the same, but they are in some sense equivalent. And then what you're going to do is you're going to solve a variety of counting problems, not just the ones I mentioned before, but some other ones using things like the additive and multiplicative principles, along with some cleverness and common sense, and some of the other techniques that we've used in our counting. All right, so now I think you're ready to work on the set of activities. The PDF file is named subsets, bit strings, and lattice paths.